Hello and welcome everyone. I am Ayaz Zafar and today we are diving into the exciting world of Angular 17. Thank you for joining me on this journey. Angular 17, the latest version of one of the most popular front-end web development frameworks, brings a host of new features and improvements. This framework, known for its robustness and versatility, continues to be cornerstone in the development of dynamic web application. In this tutorial, we are going to focus on two powerful features of Angular 17, the input and output decorators. These are fundamental concepts of Angular that allow components to communicate with each other, creating a dynamic and interactive user experience. Whether you are a beginner looking to get your feet wet or an experienced developer aiming to brush up your skills, understanding input and output is crucial. They are backbone of component interaction in Angular applications. So why are these decorators so important? Well, in Angular, applications are built using a hierarchy of components. Input allows a parent component to pass data to a child component, while output enables a child to send data back up to its parent. This two-way communication is essential for building responsive data-driven interfaces. Throughout this tutorial, we will explore how input and output can be used to solve real-world problems, enhance user interaction, and make your applications more efficient and user-friendly. We will look at practical examples, provide code snippets, and delve into the nuances of these decorators. So get ready to level up your Angular skills. Let's get started. Let's begin with the basics. In Angular, components are the main building blocks of your application. But how do these components talk to each other? That's where input and output come in. Input and output are decorators in Angular that allows components to share data. Think of input as a way for a parent component to send data to child component. It's like passing a message down to hierarchy. On the other hand, output works in the opposite direction. It allows a child component to send data back to its parent. This is like responding back to the parent component. Together, input and output create a system of communication between components, allowing them to be modular yet interconnected. Now let's set up our Angular 17 project. I will guide you through the process step by step. First, we need to install Angular CLI, which is the command line interface for Angular. If you haven't installed it yet, run this command in your terminal. First of all, open your terminal and type it npm install -g angular/cli. So this would install it globally in your machine. I already have it installed, so I will not run it again, but I will show you my version that I have currently installed here. So you can see I have Angular 17 installed with Node.js 18.16 and npm 9.5.1 installed already on it. With Angular CLI installed, let's create a new Angular project. Execute this command ng new and your project name. This can be any name, whatever you prefer. So this command scaffolds a new Angular application. When prompted, select the options suitable for your project, like whether to add Angular routing or which style sheet format to use. I already have generated my Angular project, so I will not run it again. I will just open it in my editor. That would be Visual Studio Code. You can use any of your favorite editors. To start development server, you just need to run a command that is ng-serve. So if you add -o, then it will open your browser and open the URL of your Angular server in the browser automatically. So with that, you should see your new Angular app running. That's it. You have successfully set up your Angular 17 project. Next, we will dive into the creating components and implementing input and output decorators. Now that we have our Angular environment set up, let's dive into input decorator. Input is a decorator that marks a class field as an input property. This means it can receive value from its parent component. Imagine you have a parent component and you want to pass some data to its child component. This is where input comes into play. It's like giving your child component a little mailbox where it can receive messages or, in our case, data from the parent. So let's create a child component that will receive the data from its parent. So first generate a new component by using Angular CLI. So For that, type ng generate component space child. You can give it whatever name you prefer. So with that, you can see that the child folder has been created along with its files. Now let's open the child.component.ts file in your editor, and let's define an input property here. Make sure to import the input from the Angular core, and now I will give it a name child message, and the type would be string. Okay, and we have to either make it optional or we have to initialize it with the default value. Okay, so it's totally up to us. So here child message is marked with the input decorator, which means it can accept a value from its parent component. Now let's bind this property in the parent components template. So let's go to our parent component, that is app component. But in order to use the child component in here, if you are using app module, if you are not using standalone component, then you will simply declare the child component in that relevant module. But if you are using standalone components like me, you can just directly import the child component in the imports array of the app component. Now you are able to add the selector of that child component like this. Okay, now if you reload it, you will see that the child works text that is coming from the app child component. And now let's add the input child message and give it a value hello from parent. Okay, now let's go back to the child component.html, and I will replace it with the input variable that is child message. Now you will see the message that we passed from the parent is being shown in the child. So in this parents template, we are using the child component selector app-child and binding the child message property. The value hello from the parent will be passed down to the child component. So this demonstrates how input allows us to pass data from parent to child, making our components more dynamic and reusable. And that's the power of input in Angular. It's simple yet effective way to communicate between components. Next up, we will explore the output decorator and see how it complements input in facilitating component interaction. Having understood input, let's explore its counterpart, the output decorator. While input allows a child component to receive data, output enables a child component to send data back to its parent. Output is often used in conjunction with event emitter, which is class in Angular that allows you to emit custom events. When a child component needs to communicate with its parent, it emits an event which the parent can listen to and respond accordingly. So let's enhance our child component to emit an event to the parent. We'll start by importing the event emitter and output in our child component. So let's go back to our child component.ts file. And here make sure to import the event emitter and output. So now let's define our output variable here and give it a name message event and initialize the event emitter and give it the type string that would be emitted. Now let's define a function send message to parent, and now I will use this dot message event dot emit and give it a text message from child. So here message event is an instance of event emitter marked with output decorator. This setup allows the child component to emit messages. The send message to parent function triggers the emission of our message. Now let's switch to child components template file, and here I will add a button, and within that I will just add a text send message to parent. Okay, and here I will add the click event on this button that will call a function send message to parent. So in the child's template we have a button. When clicked, it calls the send message to parent method, triggering the event. Now in the parents components template we will listen for this event. So let's go back to the app component.html, and here in order to listen it, we will register that event by using the same way that we used to capture the click event, we just need to give the same name that we have defined in the child with the output. Okay, it is the message event, and now I will call a function. Whenever this event would be triggered, we will call this function receive message, and it will pass the event or whatever payload that we will pass from the child would be passed to this function receive message. So we have to define this receive message function as well. So let's go to the TS file, and in the app component TS file, I will define it. So here the message event syntax is how we listen for the message event emitted by the child component. When this event occurs, the receive message method in the parent component will be called. So in the receive message function, I will simply console the event or payload that we are receiving. You can give it other name as well, like message. That's totally fine. And here I will add a message received message from a child and concatenate it with the message variable or parameter. So in this parent component, the receive message method is defined to handle the message received from a child. So for this example, we are simply logging the message to the console. So now let's open the console, and here I will click on that. You will see that the message is received from the child, that is hello from child. You can also display this message in the template file of the app component as well by adding a variable here that will store the message that will be received from the child. So child data is equal to, by default it is empty, but you can save the message from the child and save it in the child data property, and then you can go back to the HTML, and here you can simply add it like child data. Okay, by default it is empty, so that is not visible, but as soon as you click on that, the message from the child would be visible immediately. And that's how output and event emitter work together to allow child components to communicate upwards to their parent components. This forms a robust two-way communication system between components in Angular. In our next section, we will look at practical application of these concepts by building a real-world example. Now that we have a good grasp of input and output, let's apply these concepts to a real-world scenario. Imagine we are building an online store where users can select products and view their details. We will use input to pass product information to a detail view component and output to send a message back to the parent component when a user adds a product to their cart. So let's start by creating two components, a product list and a product detail view. Okay, both of these components have been generated, as you can see in the sidebar. Now in the product list component, we will have an array of the products. Each product will have properties like name, description and price. So let's do that. So first of all, I will define a property with an array of objects that will have property name, price and description. Now we will use the product detail component to display the details of a selected product. We will use the input decorator to pass the selected product to this component. So let's go to the product detail.component.ts file, and here I will define the input and give it the name product. So in the product list components template, we will list each product and pass the selected product to the product detail component using input. Now let's go back to the product list component.html file. Actually, as we want to use the product detail in the product list component, I need to import that product detail component in the imports array. Now I can easily add the app product detail here, and I will wrap it in the for loop. Okay, and here I will add product of products. Yes, and all right. You can also track by the ID as well if there is an ID available in your object, like ID 1, ID 2 and ID 3. So then you can simply do that product by product.id. Okay, now we will pass the product in the product detail component in this way. Okay, So next, let's handle the adding a product to the cart. We'll use the output decorator in the product detail to emit an event when the add to cart button is clicked. So let's open the product detail component .html .ts actually, and here I will add an output, and here I will add to cart is equal to new event emitter. Okay, now I will define a function here on add to cart, and we will emit the event from this function. In this product detail components template, we will add a button that calls on add to cart when clicked. So let's go back to the product detail component, and here I will add a button, and here I will add to cart button, and let's register the click event, and that will call the on add to cart function. We will also need to display the information of the product, as this component is supposed to have the details of the product. So let's add that. So we have product name, product price, and description, and here we are using the built-in currency pipe of Angular. Now let's finally the product list component. Now finally in the product list component, we will listen for the add to cart event and implement a method to handle it. So let's go to the product list component.html, and here I will add an event add to cart, and now I will call a function on product added to cart, and I will pass it the event that would be the product in our case. Now I will define this function in the ts file, and this will be receiving the product from the parameter, and now I will simply display the product name in the console. Okay, so now we need to display the product list in the app component. So let's go to the app component and import the product list component in the imports array, and go back to the app component.html, and let's remove everything, and this time I will add app products list, and you will see that we have a list of products. Let me remove the default text that product list works from here. Okay, now you can see that we have 3 products being listed here, and let's open the inspect element console, and here in the console, as soon as I click on this, let's say we have phone mini, and if I click on the add to cart, you will see that in the console it is saying that phone mini was added to the cart, and it is happening because of this function. Okay, so you can also collect these products somewhere. Maybe you have a property, a variable cart items is equal to, by default it would be an empty array, and let me define the cart items array in the product list. So by default it would be an empty array, and whenever a item would be added to the cart, we will simply push that item or product in the cart items array. So this is actually very basic and simple example just to give you basic understanding how things works, but in the real world and real project you may be using some more advanced ways to handle your code. Like maybe you will have a service where you will manage your cart items or something, whatever you prefer. Now somewhere on the top right, I will display the number of items in the cart. Okay, so here I will use the cart items dot length property that will give us the number of the items in the cart. Okay, so you can style it if you want to, like font weight bold. Okay, so now if you add this thing in the cart, it will be added in the cart. Okay, you can see that counter is also being updated. And there you have it, a simple online store where the products are listed, details are displayed using input, and actions are communicated back to the parent component using output. This example illustrates how these decorators can be effectively used in real-world applications. Next, we will look into some best practices. So after exploring input and output through a practical example, let's discuss some best practices to make the most out of these features. Following these guidelines will help you build more efficient and maintainable Angular applications. So very first best practice is using strong typing. Always define clear types for your input and output properties. This improves the readability and helps to catch errors during the compile time. So for example, let's go back to our component where we have defined the input somewhere. So I'm going to the product detail TS, and here we have the input. Right now I added the any. So instead of using any, we should have used the type product interface, and right now it is not defined, but in the real world you will define an interface, something like that, interface product, and within that you will specify the format of your product, and in this way you can add a type to your input. Next best practice is to keep components independent and reusable. So design your components to be as independent as possible. Avoid creating tight coupling between parent and child components. This increases reusability and makes your component more modular. Next best practice is to use output for events only. Remember, output should be used for the event communication, not for passing data like input. It's about letting the parent component know that something happened in the child component. Next one is limit the number of inputs and outputs. Having too many input and outputs properties can make your component complex and hard to maintain. Strive for simpler interface with fewer inputs and outputs. Next is avoid complex object manipulation. Be cautious when passing objects as input. Avoid manipulating these objects directly, as it can lead to unexpected behavior and makes your code harder to debug. So always try to manipulate the objects from the parent instead of manipulating them from the child. Next one is initialize input properties. It's good practice to initialize input properties to prevent undefined errors. You can set default values or use optional chaining in your template. So for example, here I added the question mark here. So if you don't have the question mark, and you may want to add the initialize it as well with a default value. So it's totally up to you. Next, we will talk about some common mistakes and discuss how to avoid them. First one is mutating input data. A common mistake is directly modifying the data received via input. This can create unpredictable results due to Angular's change detection and mechanism. Instead, use immutable data patterns or deep copy objects before modification. Next common mistake is overusing event emitter with output. So another pitfall is overusing the event emitter for non-event related communication. Remember, output should be used primarily for notifying the parent component about events, not as the method for data binding. Next one is neglecting lifecycle hooks for input data. When using input, it's important to handle data changes correctly. Use lifecycle hooks like ng on changes to react to input property changes, especially if the reaction involves complex logic or side effects. Next one is creating circular dependencies. Be careful not to create circular dependencies between components with input and output. This can lead to an endless loop and performance issues. By keeping these best practices and common pitfalls in your mind, you can leverage input and output more effectively, making your Angular applications robust, maintainable, and scalable. With a solid understanding of basics of input and output, it's time to delve into some advanced techniques and concepts. This will help you to manage more complex scenarios and optimize your Angular application for better performance and scalability. First advanced techniques in component communication is nested component communication. In complex applications, you might have multiple levels of nested components. Managing communication between them can be challenging. One approach is to use combination of input and output to pass data down and up the component tree. However, for deeply nested structures, consider using Angular services or state management libraries to maintain sanity in your code base. When it comes to performance, be mindful of how often your data changes and how these changes propagate through your components. Use strategies like on-push change detection to reduce unnecessary checks, and be cautious with object mutations as they can trigger unexpected change detections. Now we will talk about some integration with other Angular features. So first one is working with services. Services in Angular are great way to manage and share data across components. You can use services in conjunction with input and output for more complex communication patterns. For example, a service can act as a data store with components using output to send updates to service and input to receive data. So for example, let's suppose you are in a service. So here you will have a property private product source is equal to new behavior subject. Okay, and then you will have a variable current products. This will save the product source as observable. Now let's suppose you are in a component, and here you will use this dot product service dot current product dot subscribe, and within that callback function of subscribe you will simply use this dot selected product is equal to product, and this is a product. Okay, next you can also interact with directives. Angular directives can also interact with component properties. For instance, you can bind an input property to a directive to dynamically alter its behavior. Similarly, directives can emit events that components can listen to via output. So for example, let's suppose you are in a directive, and here you will define input in this way. Okay, and within that input you will set this dot highlight and pass it the condition. So here you are using a setter. So as soon as an input was provided to this app highlight input, we will take that input value, we will pass that value or condition to the highlight function that may be in your directive, or you can use condition yellow or transparent. These advanced techniques and interactions showcase versatility and power of Angular. By mastering these, you can build highly interactive, efficient, and scalable web applications. As we wrap up this comprehensive guide on input and output in Angular 17, let's quickly recap the main points we have covered. We started with the basics of input and output, understanding how they facilitate communication between parent-child component. We then set up Angular 17 environment and dove deeper into practical examples demonstrating how to use these decorators for dynamic component interactions. We explored real-world use cases, delving into advanced techniques and interaction with the other Angular features. Remember, mastering input and output is crucial for building interactive and dynamic web applications. These concepts are foundational in Angular, and understanding them will significantly enhance your development skills. To continue your learning journey, I recommend checking out the official Angular documentation, which is an excellent resource. For more in-depth learning, consider online courses on platforms like Udemy or Coursera, and don't forget to join Angular communities on platforms like Stack Overflow or Reddit for real-world tips and support. I encourage you to practice what you have learned today. Try building your own applications using input and output, and experiment with techniques we discussed. If you found this tutorial helpful, then please give it a thumbs up, leave your comments below, and don't forget to subscribe for more Angular tutorials. Your support helps me create more content like this. Thank you so much for watching. Stay tuned for my next tutorials about Angular. Until then, happy coding.